Welcome to another session of microwave engineering. In today's lecture, we will be discussing circulator. As you can see in the diagram, the symbol of circulator shows that whenever signal enters from P1, it will be moving towards P2. Whenever it will be entering from P2, it will be moving towards P3, and from P3 to P4, and from P4 to P1. The advantages of using a circulator is that the signal will never return it back to the same port. That means if a signal is entering from P1, it will move to P2 and vice versa, the signal cannot move. Hence, circulator can be also used as an isolator. This is a very important property of a circulator. Now let us see how it behaves. As discussed earlier, the function of circulator is that if the signal enters from port 1, the signal will be present in port 2. But signal entering from port 2 will not go back to port 1 but will be diverted to port 3. Now let us see this by an example. Suppose we have a signal entering from port 1. Now in the construction, first of all, let us look at the construction, how a circulator is created. You can see the circulator has got two couplers. Can you all see over here? I'll just use a highlighter here. Has got two couplers here. Two couplers. The function of this coupler is to give a phase shift of 90 degrees when it is passing through it. But can you see, whenever it is passing through it, a phase shift of 90 degrees is given whenever it is going towards downward movement or upward movement. Straight movement does not give a phase shift. That is a property of a coupler. And two additional phase shifters have been introduced of 180 degrees. Can you see over here? I'm highlighting it when it is moving from port 1 to port 2, and 90 degrees whenever it is coming from port 2 to port 1. The similar type of phase shifters are also implemented in the lower half of the waveguide. Can you see over here W3 when it is going from left to right, 0 degrees phase shift, and when it is moving from port 4 to port 3, 90 degrees phase shift. Now let us start by allowing the wave to propagate from port 1. I'll use a similar pen maybe to highlight it better. Now when the signal is traveling from port 1, I'm using a blue color line. Whenever signal is traveling from port 1 and suppose it is moving in the direction, you can see the line how I'm trying to propagate. It is reaching port 1. When it is moving in the upper side of through the primary guide, you can see what happens is that it is not going through the coupler. It is not traveling towards the coupler downside movement. So the 90 degrees phase shift is not given to this propagating wave. As a result, you can see a 180 degrees phase shift will be introduced by the phase shifter because the direction of arrow is in this way. I hope you agree with it. So by the time the wave enters the port 2, already 180 degrees phase shift will be there as it is passing through the primary waveguide. For the same wave, if I am taking it from the downward, you can see over here, you can see the blue line. When it is going down, 90 degrees phase shift is already given. It moves like this, 0 degrees phase shift. Right now it is just 90. It again comes over here. Since a diversion, a change takes place, another 90 degrees, now the phase difference is 180 degrees. Since the phase difference between the wave is 180 minus 180, it is 0 degrees, signal will be present in port 2. Now let us see for the other one. Suppose I'm going to use a red color line over here. What happens over here? You can see over here, 1 minute. Continuing from the earlier slide, suppose the signal is propagating from port 1 and it is moving directly to port 4. Now when it is moving towards port 4, I am traveling through the primary waveguide. So what happened? At the first phase shifter has already given 180 degrees phase shift, then it is going down. When it is going down, what will happen to when it is going down? Again here a phase shift took place in the coupler 2 of 90 degrees. So 180 degrees over here and the 90 degrees over here together will become 270 degrees when it is reaching port 4. Suppose the wave is traveling in this way. You can observe the red color line. It is traveling over here. A diversion took place, so 90 degrees. Here 0 degrees of phase shift is there. By the time it reaches over here, it will be only 90 degrees. So that means the phase difference between the two waves is 180 degrees. Power or your signal will not be present in port 4. Now, what will happen in port 3? I leave it as an assignment to you. Try to recollect whether the signal will be there or not there. Thank you very much. I hope you understood the circulator in detail. Thank you.